Hey Soph, it's Miss Lane. I'm just going to go through this 5-1 quiz review. The questions on the quiz are very similar to the review. So if you use this to help you with the quiz, that'll probably bring your grade up a little bit. So part 1 was mid-segment. If F, G, and H are all the midpoints of the sides of the triangle, FG is 9, GH is 7, and CD is 24, find the perimeter. So for our mid-segment, when you connect the midpoints of the sides of a triangle, that's called a midsegment. There are two things that we know about the midsegment. Say GH, that's your midsegment. That is parallel to CE, so the opposite side, and GH is also half the length of CE. So because we're told GH is 7, we know that CE is 14. We're told that FG is 9. That means the opposite side has to be double 9, which is 18. And we're told CD is 24. So to find the perimeter of this triangle, you just have to first find these two missing sides, which we did by doubling the midsegment, and then add all three together to get the perimeter. For number 2, we're asked to find DE. We're still talking about the midsegments, and we're given DE. The expression is 4x plus 1. AB is 11x minus 25. Our midsegment, which is inside of the triangle, we know is half of the opposite side. So to create an equation where these expressions are equal, we have to do 2 times this little segment to get to this larger segment. So 2 times 4x plus 1 equals 11x minus 25. To solve for x, you have to distribute. And when you solve, you get x equals 9. But the question is to find DE. So to find DE, we just have to plug back into this original expression. 4 times 9 plus 1 is 36 plus 1, which gives us 37. So that's if you're looking for the length of a side. For number 3, we're finding the value of x, but notice we have degrees, so these are angles. For the midsegments, we know that these two lines are parallel, so our angles are going to be some kind of angle pair. Notice this is our transversal here. These two angles are on the inside of our parallel lines on the same side of the transversal, which means they're consecutive interior angles, which means they have to add up to 180 degrees. So to solve for x, we're going to do 5x minus 24 plus 8x plus 9 equals 180, and then we just solve for x. For part 2, perpendicular bisectors and angle bisectors. For all of your perpendicular bisector and angle bisectors, you're setting your expressions equal to each other. So we have these two expressions. They have to be equal to each other. So first we solve for x by setting them equal. We get x equals 20. To find JK, that's this side here, you just plug back in for x. So 2 times 20 minus 26 gives us 49. For number 5, find AB. We have two expressions here. They're equal to each other, so set them equal and solve for x. You get x equals 14. Then to find AB is the entire base of our triangle. So you can choose either of these expressions to plug into and then just multiply by 2. So I plugged in for AD, which is 5 times 14 minus 11, which is 59. So this part here is 59, which means this other side has to be 59. So the entire length is 2 times 59, which is 118. For number 6, find QR. So we're given these two segments here, these expressions. We set them equal to each other again. So 7x minus 40 equals 5x minus 8. When we solve, we get x equals 16, but we're trying to find QR. So we're just plugging back into this expression here. 5 times 16 minus 8 gives us 72. For number 7, now we're given two angles here. This line, WZ, is the angle bisector, so we're setting these equal to each other. When we solve, we get x equals 7, but we're trying to find the measure of angle WXZ, or XWZ. XWZ is represented by this expression, 8x minus 32. So we plug in 8 times 7 minus 32 gives us 24 degrees. Now, centers of triangles, circumcenter and incenter. The circumcenter, remember, represents our perpendicular bisectors, and the incenter represents our angle bisectors. So for number 8, if H is the circumcenter of triangle BCD, find each missing measure. First thing we know about the circumcenter is that every single side is split exactly in half. So if this entire side, BD, is 24, that means that each piece is 12. If EC is 7, BE is also 7, and the entire side is 14. So first we can figure out A and B. GD has to be 12 because the entire side is 24. BC has to be 14 because 7 plus 7 gives us 14. Now for C, we have EH. EH is this line here. If you don't know anything about these lines, we have to use the Pythagorean theorem. So we're using this right triangle here. We know that our hypotenuse, which is across from the right angle, is 13. One of the sides is 7. The other side we're going to call x. So to solve for this, we're going to do x squared plus 7 squared equals 13 squared, and then solve for x using a calculator, which is 11. So that's C. For D, let's erase some of this so it's easier to see. For D, we're trying to find FD. FD is this piece of our side here. We know that HF is 3, and we know that HD is 13 because from the circumcenter to each of our vertices is the same length. So if BH is 13, that means CH is also 13, and HD is 13. So again, we're using Pythagorean theorem. Hypotenuse is 13, so x squared plus 13 squared equals, or x squared plus 3 squared equals 13 squared. When you solve for x, you get 12.6, so that's D. This piece is 12.6, which means this piece of the side is also 12.6. To find CD, you do 12.6 plus 12.6, or 12.6 times 2, which gives you E. For number 9, we're finding BC. So we're given these two pieces of our side. They're congruent, so we set them equal to each other and figure out that x equals 6. To find BC, that's our entire side, we're going to plug in for either of these expressions. So I'm plugging in for EC. 10 times 6 minus 33 gives us 27. So if this piece is 27, this piece is also 27. So our entire side is 2 times 27, which is 54. For number 10, P is the incenter. So incenter means we have angle bisectors. If P is the incenter of triangle JKL, find each missing measure. And for the incenter now, from the incenter to each of our sides are congruent. So if PM is 8, PN is also 8, and PO is 8. Also, your segments on opposite sides of the vertices are congruent. So if KO is 17, NK is also 17. So first we can find A, NP is 8, B, NK is 17, just by looking at the sides that were given. For C, PK. PK is from the incenter to the angle. So we're going to have to create another right triangle and use the Pythagorean theorem. We're looking for the hypotenuse, which is across from the 90-degree angle, so we're going to call that x. So 8 squared plus 17 squared equals x squared. Solve for x, and we get 18.8, so that's C. And for D, we're looking for LO. LO is this piece here. So we create another right triangle. Our hypotenuse is 13 because it's across from the right angle. One of our sides is 8, the other side is x. So to solve, we're going to do x squared plus 8 squared equals 13 squared. And when you solve, you get x equals 10.2. And finally, number 11. Number 11, K is the incenter. So that means every single angle in your triangle, B, or D, F, and E, are all being split exactly in half. So we're given that this piece of our angle is 19, which means this piece is also 19. This piece is 27, so this piece is also 27. Now to find angle E, we know all three angles of our triangle have to add up to 180. So to find E, we could do 38 plus 54 minus 180. Plus 54, and that's going to tell us what angle E is, which is 88 degrees. So if the entire angle E is 88 degrees, that means each piece is 44 degrees. And that's it. You didn't even need your... Oh, to find x, yes. So AFED, angle FED is the entire angle E, so that's 88 degrees. For B, DEK is half of that angle, so it's 44 degrees. And then to find x, we're given this expression, 17x minus 7. 17x minus 7 equals 44, because it's only half the angle. And when you solve for x, you get 3. I hope this video helps. Try to use this and the work that I've shown to answer a few of the questions on that quiz and submit as soon as possible. I hope you and your families are staying healthy. I miss you guys. I miss your whole class. If you have any questions, please don't hesitate.